So the shortest path asset is based on my shortest path tutorial. So there you can go and see how it works, how it's built, and you also see at the end how the asset here works. So, but I will make here a little recap, so go quickly through. So let's bring in the shortest path asset here. So you can see you need the object where you want to build the shortest paths on which mesh. So this is here my connect object here. This is just a plane with a poly reduction. So let's bring in here our connect object. Now we need two selection where the shortest path starts and where it will end. So we need two selections. I already have here a selection ready. So let's call this is start and then duplicate it here, and this one is end. Now we want to build some procedural selections. So let's add a spherical field and oops, maybe hide this one. Let's move this up here. And now to visualize here our points, we can use our visualizers from the visualizer tutorial. So as I explained, let's go here to the models, then go to Druckli models, and then you have here the selection visualizer for points. Bring this in here, then let's bring in here our selection. This one is for the start. Also bring in the connect object. Maybe let's make them a little bit bigger. So now we can see here, these are our start points. Now we can define our start points. Let's make the same here for our endpoints. Bring in the endpoints, and maybe let's make another color. Go to basic. Let's make them kind of pink. Then let's add an additional spherical field for our end selection. Bring this in here. Let's move this over here, and let's make this smaller. So now we have here our endpoints, and these are our start points. Let's go to the shortest path. Let's bring them in here, start and end. Let's hide here the mesh. So now you can see we have here the shortest path from the endpoints to the start points. Now you can move them around. Yeah, and it will always update. And then of course, how many search iterations do you want from the start to the endpoints, and if you want all endpoints or just one endpoint. And then of course there are also some example files. Let's go to scenes, Druckli scenes, and then there you have the example files also from tutorial. So same here with the head. So, and then there is the one here, the example with the trees here. So I explained those all inside the shortest path tutorial. Okay, let's move to the next one. For the Mycelium Grower, there is also a tutorial on my YouTube page where I go in depth how the Mycelium Grower works. And here is just a final asset that you can use here. Just drag it in, and all the settings will be explained at the end of this tutorial. So just press play here and it starts to grow. And of course, there is also an example scene here. So you can open the example scene here and press play and watch the mycelium grow. For the point grower, there is also a YouTube tutorial where we build our own point grower, and at the end I will explain all the settings that we have here. Just to round this up here is the point grower now as final asset. So let's throw it into a volume builder. Maybe let's set the voxel size to 1 and then the points here to 1.1. and leave the setting here as default, and let's have a look. And now let it grow. And then also here for the point grower, there is also an example scene where you can dive in. And yeah, that's it here for the point grower. Let's jump to the next one. The Spiderweb asset here is based on my Spiderweb tutorial. So if you like to know how it works, go and watch tutorial, and also the full settings will be explained at the end of the tutorial. Here just a quick introduction how to add your own spider threads here. So add the Spiderweb asset, then it works with points. So the easiest and the best way is to, maybe let's go to the front view, just add a spline or draw a spline. Then here go to the spline pen, start to draw a spline, and then feed this in here to the Spiderweb as a child. And you can see on each point it will build a thread. So maybe let's select all points, delete the points, and then you can start to add your own spiderwebs. And then for all the settings, go and watch tutorials. At the end, I will explain the whole capsule. And also for the Spiderweb capsule, there is an example scene. Go to scenes, here Druckli scenes, and then there is the Spiderweb example. There you have 3 different types of spiderwebs, all with different splines here. Also press play and see how they move. Okay, let's move to the next one. The array connector is based on my fast plexus tutorial. This one's a little bit obsolete because of the new constellation asset from Rocket Lasso, but let me still quick explain how it works. So we need a points object here, so we can use a matrix object for this, maybe 10 by 10 by 10. Let's make them smaller and then add some randomness. Here we go. Let's bring them in here. Oops, not the random one. Let's bring in here the matrix object. And now first we can define how many connection each point can have. So maximum neighbors of 10. So we can decrease here. So we have just like 2 connections. Let's go back to 10. Then we have loose connection at 40 centimeter for now. So when we go maybe to this one here, when we decrease here the loose connection at 40, you can see here if the distance here is bigger than 34, then the connection disappears. And you can also say scale by distance. So now we have here the full connection is if they are closer than 20, and then it loses the connection if they are maybe say 40. So you can play around here with those to let them grow. So when we maybe add some animation here, some noise, 20, let's go back. Make them smaller, scale here, let's press play, and you can see they grow depending on the distance to the neighbors. And then there is also a ramp, so you can ramp, make kind of an easing for the growing. So let's make a harsh ramp here. Let's press play. Yeah, and of course there are some example scenes here. So this one here, we have a huge constellation here. And this one here, this one is with particles. Let's press play. Let's press render, and then let's move to the next one. For the match size modifier, you will find a full tutorial on my YouTube channel. There I go in depth how the match size modifier works. And the only difference here for the new version here is you no longer have to define if you use the match size here inside of the object manager or inside of the scene nodes context. Now the match size will get this automatically. And here inside of the example scenes, you will have also like two match size examples. These are the same examples as from the tutorial. Okay, let's move to the next one. So the reaction diffusion asset is based on my reaction diffusion tutorial. So if you like to know how it is built, you can go and watch the tutorial. So let me explain how it works. So here is our asset. And then what we need here, because it's a generator, we need a mesh where we do the reaction diffusion. So let's add a plane. We need a lot of subdivisions. Maybe start 200 by 200. Add this to the reaction diffusion. Then what we need here, first we need a chemical, so a vertex map where we decide the where the chemical reaction will be. So let's deactivate it. Let's add a vertex map. Then let's add a random field. Let's make this a little bit bigger. Bring in a curve here. Let's add some contrast here. Maybe something like this. And then where we have the yellow areas here, there the reaction will start. So this is kind of the start chemical here where we want the reaction to take place. So let's activate it. Let's maybe add a material. We can see we have here a reaction diffusion vertex map. Let's build a material. Let's add a vertex attribute. Bring in here our reaction diffusion vertex map. Add this to the color. Add this to the reaction diffusion so we can see it. And already we can press play. And we can see we have here a reaction diffusion effect. So let me explain the settings. First here is the chemical burr, how this is kind of the strength, how strong we like to mix our chemical with the initial chemical. So pretty simple to explain. If you have your lower values, you have more like those smaller tendrils. And if you go, for example, here, let's blur it 5 and 10 times, like always doubling here is a good thing to do. So let's press play. And now you can see those tendrils get way bigger. So, and then we have here an add chemical amount. So this is like on every frame, how many new chemical we want to add from here, our vertex map. So if we go here to 0, you can see this will die out here, so there will be no new chemical. So keep this stuff here kind of low. And you can see we're still adding here new chemical. Maybe it's a bit hard to see, but if you have a vertex map where maybe you want to run something over the mesh and add new chemical, or maybe some particles that run over the mesh, then you can add new chemicals where those particles are, for example. So let's go further. Then we have here the exposure vertex map. If you have no vertex map, you have like an even exposure value over the whole mesh. So now you have here a strength of 20. So this is how strong our chemical reaction is. So let's add an additional vertex map. Maybe let's call this exposure. Whoops, exposure. Then let's also add a random field. For example, let's make this way bigger, something like this. Then add a curve again. Let's bring in some contrast here, something like this. So we have those bright areas and the dark areas. Then activate the reaction diffusion again, bring in here our exposure vertex map. And you will see if you have here a minimum exposure and a maximum exposure. Now, if we say here 0, then on the darker areas we have no chemical reaction. So you can see here it still adds here a little bit of chemical, but it will die out because we have here no reaction. So here try to find a sweet spot for some nice results. Maybe let's say 7 to 20. Let's check. Then you have here less. Maybe let's go back here to the initial 1/2. Let's check. Yeah, you can see here's close. Yeah, there is not a lot of reaction compared to here the brighter areas. So yeah, play around with these settings. Then you have here the exposure strength. This is the overall strength on those two values. And here the exposure lift. This is like adding an overall value to our exposure compared to the strength. Like strength is multiplying the exposure and the lift is like just adding a value. Then the neighbors, let's check what the neighbors are doing. So the neighbors is how many neighbors each point on our mesh will have for the actual reaction. So, and if you have no vertex map here, every point will take 20 neighbors. So maybe let's show the mesh. So we zoom in here. So we have every point here. Maybe let's deactivate the work plane. So every point will have 20 neighbors to look at to make a reaction. So if we maybe remove here the exposure here and use the exposure here for the neighbors. So you can say, okay, where we have the dark areas. So we have here the dark areas, we have like 20 neighbors, and in the bright areas you have 30 neighbors. So let's activate this again. And maybe let's say 5 to 40, and you will see there's a big difference. Let's press play. You already see, I think 5 is not enough here. So you get here some artifacts where let's say 10 to 40. Let's press play, and you can see you have here these bigger tendrils, and here you have those smaller tendrils. Maybe let's bring the exposure back to 20. So have a stronger reaction, and yeah, you can see you can play with those values. Maybe let's go to even to 100 and here 20, and maybe add some additional subdivision, 300 by 300. You have a nice result here. Of course, it gets a bit slower, but yeah, you can see you have those bigger tendrils and those smaller ones here. And then the last setting here, of course, the maximum distance is how far each point can search for its neighbors. So around 100 is fine for here, but if you have a bigger mesh, of course, make this bigger. And then you have the last setting is like updating each frame. So if you have an animated vertex map here for the neighbors, activate here this checkbox. So if you like to change the amount of neighbors for each point over time. So, but of course, this has to recalculate the neighbors on each frame. So this makes it a bit slower. Then let's go here to the post blur. The post blur just adds some additional blur here after the reaction. So if you activate it, you can already see here, we add just some blur here. So we have a bit more a blurred version here of our reaction. Is especially very helpful when we work here with the last setting, with the displacement. So if we bring in here the displacement, let's go back here, we can say activate the displacement, and you already see we have here displacement depending on our reaction. Of course, you could do the displacement with other tools, but this is just directly integrated into the asset. So then here, of course, you can define the height, maybe let's say 5, make it a bit higher, and then maybe add some additional blur, and maybe go to 4 here. With this curve here, you can define here the profile. So if you like to make it more sharpen, but I think this looks fine here like this. All right. Maybe just add 2 here for the blur amount. Let's press play, and then you have also a displaced reaction diffusion. And it will look like something like this. Great. Then of course we also have here some examples here, some example scenes. So on the scene you have a simple reaction diffusion. So this is just a simple example with some settings here. So nothing special, just if you want to know how a simple reaction works. Then the second one, let's bring this in. Here we have let's show the vertex maps. We have here an helix here, and this helix grows with a trim spline modifier. So it will grow along the spiral spline here and adding new chemical. And this is our chemical vertex map. And then we have the exposure chemical map is also, it's like it has a gradient along the spline here. So let's have a look how this will look like. Let's press play. Let's hide the exposure here. And then the last example is actually the example from the tutorial. So here we have this cube. This cube runs along our sphere here and adding new chemical. And then we have also an exposure and a neighbor's vertex map to add some variance over the whole surface. So let's press play and have a look. And then I think that's it.